Today I want to talk to you about the Ruby LSP and the 2 years of the Ruby LSP. So we actually started the project 2 years ago. It just completed 2 years, 5 days ago on February 24th. And so I want to talk a little bit about the current state, what we currently have, what we have planned for the future, and a little bit of the internals of how it works. So as I mentioned, my name is Vinny. I'm a staff developer in the Ruby DX team at Shopify. Our team works on different aspects of the developer experience for Ruby. So one of the things we do is maintain the Ruby LSP. We also contribute to Ruby Debug, the official debugger, and IRB, the REPL. And we also have a part of the team working on gradual typing through Sorbet and Tapioca. If you want to know more about me, you can find me at Vinistock on X and GitHub. So first of all, for those that aren't familiar, what is the Ruby LSP? The Ruby LSP is an implementation of the language server protocol for Ruby that's also made purely in Ruby. So it's made entirely in Ruby, and it provides rich features in the editor for the Ruby language. So here in the slide, we have 3 links. The first 2 repositories are the main repositories for the Ruby LSP. First one is the VS Code extension, and the second one is the server implementation, which is a gem that you can use with any editor. It doesn't have to be VS Code. I should mention that we're actually in the process of becoming a monorepo, so the first one's going to go away very soon and be archived, but for now both exist. And the third link, the Ruby LSP is the default recommendation for working with Ruby files in VS Code. So this is the VS Code documentation for the Ruby language, which includes some information about the LSP. Some of the features that we currently support, we have support for go to definition, hover, and completion for require paths, constants, modules, classes, but we are still working on support for methods. So we do have early support for a few types of methods. We don't have support for everything. We're working on it. Another feature that I personally really enjoy is code lens, which are the buttons on top of unit tests to be able to run them through the test explorer in VS Code, run them in the terminal, or launch a debug session directly from the test. So I find this to be very, very handy. I think this is probably one of the features I use every day. We have formatting, diagnostics, and quick fixes. This depends on which formatter and linter you're using, but for Rubocop we have all of those. And there are also some diagnostics you get regardless of your formatter and linter, like syntax error diagnostics. If you make a mistake, the Ruby LSP will tell you that there's a syntax error in the file. This is coming from the Prism parser, the new Ruby parser. And one of our most recent features is the dependencies view, which shows you all the dependencies of your project and allows you to navigate through them. So we know what the Ruby LSP is. It's a language server implementation, but what is a language server for those who aren't familiar with that? The idea is that it's a separate process that runs on your developer machine to provide features for the editor. So the editor spawns a separate process, and that process is responsible for serving features back to the editor. If we were to write what the editor does in like a little Ruby script, it would be something like using the Open3 library to spawn a separate process. So here we're spawning the Ruby LSP process, and we keep handles for standard in, standard error, and standard out. And we use those pipes to communicate to the process, to the server. So standard in is used to send requests to the server, and standard out is used to receive the responses back, all using JSON. So the form of communication is programming language agnostic. It doesn't matter if the editor is connecting to a Rust LSP or a Ruby LSP, the communication is always JSON. It doesn't matter what language it's providing features for. And the standard error pipe is used for output. So you can basically log anything you like, and it will just show up in the editor's output. There are 2 types of messages that an LSP can send or receive: notifications and requests. And the only difference between the 2 is there are no responses expected for a notification. So you're just notifying the other side, that something happened but you're not expecting anything back. And requests, you actually do expect something back. And the communications also flows on both directions. The server can make a request to the editor and can notify the editor as well. So if we were to take a look at the sequence of events when the events that happen between the editor and the server as we're working on something, it would be something like this. Imagine we open a file in the editor. First, the editor notifies the server that a new file has been opened, and it's the responsibility of the server to have an internal representation of all of the documents that are currently open and what their state is. The reason is because when we receive other feature requests, you're not going to receive the full contents of the file again, you just receive an identifier, and the server is expected to have the internal state of that document based on the identifier. So after we open the file, immediately after that, the editor sends a wave of different feature requests to compute features so that they're available for you immediately after you open the file. So like folding range, where the code can be folded, and the server has to respond to that. If we were to edit this foo class and add a method definition, the editor will first synchronize the text, notifying the server that the contents have changed. And then after the server updated its representation, then it will send another wave of feature requests. Since the contents have changed, the results of the features may have also changed. You may be able to fold the code in different places. So you get another wave of requests. Although it's not a part of the specification for language servers, I like to use this mental model to think about the different types of features and communication that happens, which is the automatic requests and the manual ones. And the automatic ones are basically always triggered as the consequence of you opening or editing a file. So you don't trigger them directly. You open or edit a file. The editor will notify the server that the contents have changed, or you open a new file, and after it synchronizes the text, you then get a bunch of automatic requests triggered, like completion, for example. If you type in a character, it will first it will put in the character and then try to look for completion options for whatever you're trying to type. Same thing for where you can fold the code, semantic highlighting, or populating the file outline in the editor. So the reason I like to think about the automatic requests separately than the others is that they're very critical for performance. Anytime you type something, you get a wave of many different requests sent to the LSP, and you have to respond really quickly or else you lose responsiveness in the editor. And the manual ones are more direct, like you request to go to a definition, or finding all the references to a constant, or renaming a class, and then the thing you requested just happens, it's straight away. You also always want good performance for these as well, but it's more tolerant for slower processing of things, because it's not on every key press, it's just when the user requested it. And what's the advantage of having this separate process running on the machine to provide these features? The main advantage, in my opinion, is the ability for programming language communities to be able to collaborate on better developer experiences. So if you take a look, before we had language servers, and you wanted to have completion, formatting, all of these rich features for Ruby implemented into every editor, you would need to create a Ruby plugin for each one of them. Each one of these editors use a different programming language, so you need to use a different programming language to create your plugins, but also you have a different API that is exposed to the plugins by the editor. So you can't just take a Vim plugin and use it in VS Code directly. You would need to re-implement the same features over and over and over, and the same story for any other programming language. Sorry, my automation skipped, but it was supposed to show other programming languages. And so after that, with the language server, you have a much different reality where each one of the editors can just implement the protocol that communicates with JSON, and then can all connect to the same server and get those same features. So we can all collaborate on the same server, and everybody gets to enjoy the new features. So that's basically what I wanted to talk about in terms of what is the Ruby LSP and what is a language server. But now let's take a look at how the Ruby LSP analyzes our code. And we're going to use as example folding range, which I think is one of the simplest features in the specification, which is where figuring out where you can fold the code. Like in this case, you would be able to fold the foo class and possibly the method declaration for bar as well. For this request, what we receive as a parameter is just the document identifier, so just the URI for the document, and when at this point, the server should already know what the state of the document is. So the text has already been synchronized, and we receive a request to compute the ranges for this document. The editor is going to expect back an array of all of the different ranges present in that file. So the start line, the end line, and the kind of range for everywhere that you can fold the code. The idea here in terms of what we're going to do for analysis is that we have our Ruby code synchronized from the editor as a string. We need to turn that Ruby code into something more useful, like an AST, an object that we can make inquiries about what is declared in our Ruby code. And then we perform the analysis required to collect everywhere you can fold the code and return that back to the editor. For parsing, we use the new Ruby parser called Prism. And for the analysis, we're going to use a combination of the visitor and the observer pattern. So in terms of parsing, I'm not going to be able to go into a ton of detail, but basically it is the act of turning a Ruby code string into a more useful object, into a tree object that looks kind of like this. If we had a string for that foo class, we would have an AST that looks kind of like this, with a class node at the very top, with two child nodes, the constant foo and the method declaration for bar. And then the bar declaration has a child of its own, which is the string hey. And with this structure, we can traverse it, collect information about what is defined in our file, and then return the information back to the editor. So let's start by taking a look at the visitor pattern and how we use it to traverse an AST in an organized way. If we were to implement this from scratch, we would start by creating a parent class, visitor, with one main API, visit. This receives the node that we want to visit, the node that we want to traverse, and it just invokes accept on it, passing to the node the instance of the visitor itself. For this to work, every single node type that we can have in our Ruby code needs to implement the accept method. And their implementations are all analogous. You take the visitor that you just received as an argument, and you invoke the handler for that specific node type. So for a class node, you invoke visit class node back in the visitor. For a module node, you invoke visit module node back in the visitor. This is where the double dispatch idea comes from. The visitor first asks the node, please invoke the right handler for your node type on me, and then you get that invocation back and you get the chance to handle that specific node type. It's basically a way of avoiding a huge case statement where you handle each type of node in a branch. To conclude the implementation, we need to add the recursion part, so how we continue to traverse the AST for every node that we find. And the idea is that we default all of those specific node handlers to simply visiting each one of the child nodes. So basically you visit a node, the first thing it's going to do is take a look at the child nodes and visit each one of them, but then when you land on one of the child nodes, it's going to do the same, and you recursively keep going until you've been through all of the child nodes. And the main advantage of this idea is that you get to very neatly encapsulate logic of what needs to happen for each node type that we encounter in our code. So here, we're using Prism Visitor. The Prism gem, it has the parser, but it also has utilities like the visitor class. So you get that out of the box. And you can override those specific node handlers to do something when you find that node type. So in this case, we're going to print hi and the name of the class being declared every time we find a class. And invoking super at the end just gives you the default behavior from the parent class, which is continue traversing the child nodes. If we wanted to use that visitor, all we have to do is parse the code using Prism. So here we're parsing file, but you can parse a string of Ruby code, instantiate the visitor, and then visit the AST. And this is already going to print hi and the name of every declaration class that you find. So this is the visitor pattern part. Now let's take a look at the observer pattern. and then we'll take a look at how we combine the two. The idea of the observer is that it allows us to have separate concerns and separate logic that is triggered based on similar events or the same events. And that's one of the reasons why we use it in the LSP. So if we had like a dispatcher class, the idea is that you get to register for which events you want to handle on that dispatcher. So on a certain event, I want to do something. And then every time that the dispatcher fires that event, that handler gets invoked for you. So you could register as many different handlers as you like for as many events as you like. And then when the dispatcher fires those events, you would get all of those handlers invoked for you. The idea for the Ruby LSP is that we use a mix of both. So we use the observer pattern, but it is actually a visitor that's firing the requests to the listeners, to the subscribers. So the dispatcher that we have is a visitor, and it will fire events for each node type that it encounters while traversing the AST. Let's begin by looking at the implementation, and then we'll see how we use this. So if we were to implement the dispatcher from scratch, we begin by using the visitor, so it inherits from visitor as well. And we initialize it with a hash of listeners. So listeners is just how we call the objects that can register for events on the dispatcher, but they're not any specific class. The listeners hash is going to have it's being initialized with a default of an array. The format is that the keys are event names that they want to handle, and the values are the array of objects that want to handle that particular event. We need a way to register for events. So here in the register method, we receive an object, a listener, that wants to handle an array of events, a splat of events, and for each one of them, we put the listener into the array of interested objects that want to listen to that event. And the final part in the implementation is redefining all of those node handlers. So for each one of them, we want to fire events based on the node type. In this case, if we visit a class declaration, we want to take all of the listeners that have registered for the onClass node event, and for each one of them, invoke the handler for onClass node. And so this implementation actually has an implicit dependency. It requires that all of the objects that have registered for an event also define the handler, otherwise this is just going to fail. So all of the features we have implemented in the LSP are basically just listeners that respond to a set of different events happening in the AST, so a set of different nodes being found, and the information is all collected in the state of that object. So for example, let's take a look at a visualization. If we had our food class here and we parse it, turn it into an AST, and then we create two listeners, one interested in class declarations, and the other one interested in class and method declarations. Both of them would register in the same dispatcher, and then when we told the dispatcher, hey, go and traverse the AST, it would start firing events based on the nodes that it finds. So for the class node, it knows that the listener 1 and 2 are interested, so it fires both events. It continues traversing, goes to the constant foo. No listener has registered for constant events, so we continue traversing. We find the method declaration, fire the event for listener 2, and then continue traversing until we exhaust all of the nodes in the AST. We actually compute multiple features at the same traversal of the AST, thanks to this approach. And this has been very critical for our performance because these are all the automatic requests that I mentioned before that happen on every key press. So the idea here is reducing method calls. Basically, if we take a look at our folding range listener implementation in the repo, it's about 270 lines of Ruby code. But that already produces about 1,000 visits because of the whole AST structure, which in a double dispatch implementation is going to be about 2,000 method calls, give or take. And so if we were to traverse the AST 5 times to compute 5 features, we'd get something of the order of 10,000 method calls, when instead we can compute everything with the same 1,000 visits by using this pattern. And it really, really improved our performance for all of these automatic requests. not sure why it's not updating there. Okay, there we go. So let's create the listener for folding class declarations using all we built so far. The idea here is that you can create any class, any type of object that you like, and you take the dispatcher and you register your object for all of the events that you're interested in handling. So in this case, we want to fold class declarations, so we're registering this object to handle on class node, and then we're just initializing an array so that we can keep track of all of the ranges that we found as the events are dispatched. We know we need to declare the handler for that event. So on class node, what we're going to do is take the location of the class declaration, so where it was found in the file, and then we're going to push a range for that so that we can return it back to the editor. If we were to use this listener, it would be almost exactly the same thing as we had before in our visitor example. You parse a file or a string of Ruby code using Prism, get an AST back, you instantiate the dispatcher, which is going to fire everything for us and traverse the AST. We instantiate our new listener class, which is then going to register for the events on the dispatcher. And as we dispatch, then the events are going to be fired. And here, dispatch is basically just an alias to visit. So it's just telling the dispatcher, go traverse the AST and fire the events for the listeners. And by the end of the traversal, the state of the listener, the state of the folding range listener is going to be populated with all of the ranges that we found for classes, which are ready to be returned back to the editor. So this is an example using one listener, but if we wanted to do the same as the Ruby LSP and have multiple listeners be populated in the same traversal, the idea is that all you have to do is instantiate more of those classes that will register for events on the dispatcher. Since here, like for example, we have folding range, then we have document symbol, which has its own set of events that it is interested in and its own internal state. Same thing for semantic highlighting. And after everything's been registered, you traverse the AST once, and by the end of it, all of the listeners are going to have the response for all of those separate features. And that concludes the implementation for folding ranges. So I want to talk a little bit about what is next for the Ruby LSP, both in terms of short-term things and longer-term things. In terms of short-term stuff, we want to make the Ruby activation a little more robust. So basically, the Ruby LSP, it tries to automatically detect your dependencies so that we index the right gems automatically and you get to go to the definition and jump straight to the gem code. But for that to work, we need to find the right Ruby version for that project. We need to have your bundle satisfied, so bundle install needs to have a run before. Otherwise, the gems are not there for us to index. And sometimes this fails catastrophically, and we need to handle the error scenarios with a little bit more grace so that it guides the developers into fixing the issue. Full support for going to definition, showing documentation on hover, completion, and signature help is probably the most requested feature that we have from the community so far. We're working on that. It's partially supported, but there's still a way to go to fully complete the feature. We want to add more refactors, so we have only one refactor right now. In fact, Jenny added the refactor, which is extracting a selection in the editor to a local variable. We can also extract to a private method. We can extract a bunch of methods into a module. We can switch from a do-end block to a curly brace one-liner, or switch if for unless. There are many, many things we can do with refactors. Other features, renaming things, like tell the editor to automatically rename a constant, and it just goes and finds all the references and renames that for you. Finding all the occurrences, all of the references, showing the ancestors for a class or a module, so showing the type hierarchy, everything that's been included, extended, prepended. And we also want to add more debugging features. So we do have a few debugging features. I showed in the beginning the debug thing for unit tests, but there's a lot that you can do integrating a language server and the debug server, like showing the values for your current debugging session directly inside your file is a neat feature that can be done by integrating the LSP with the debug gem. I really believe that great DX comes from good integration. And one of the main challenges for this is that the Ruby tooling ecosystem is quite fragmented. We have a ton of different formatters, a ton of different linters, test frameworks, Ruby version managers, and it would be really hard to integrate with every single option from the Ruby LSP code directly. Just in terms of version managers, I was talking about this on the Bundler Slack one of these days, and it's like, I think we support 8 different version managers. It's like integrating with all of them is a lot of work, and we would become a bottleneck for the community if everybody wanted to add features into the Ruby LSP's main code base. And so we're trying to provide a one-click setup experience with an experiment. And what we want is for projects to get features based on what the projects are using, based on the dependencies. So if you have a type checker configured in the project, the Ruby LSP would automatically get more accurate and give you better results. It would hook into your formatter. It would identify your test framework and be able to run tests automatically for you, things like that. And the idea that we're experimenting with is the concept of what we're calling as add-ons. And we were discussing the name before, but we didn't call this extension or plugin because it used to be confused a lot with the VS Code extension or a Vim plugin, and we couldn't find a better name that wouldn't get confused, so we went with add-on. But the idea is that it's a way for other gems to enhance the Ruby LSP built-in features. And so in this case, it would become a little bit more than just the language server, but rather like a little platform to deliver integrations into the editor. We want the Ruby LSP to automatically be able to detect which add-ons should be loaded based on your dependencies. So very recently we did this for Rails. If you're working on a Rails app, you automatically get Rails features now. But we're trying to find a way to do this at scale, so that we don't have to keep a list of what we need to activate based on your dependencies or anything like that. And yeah, here's the example of the Rails add-on for the LSP. There are many challenges that we still don't know with add-ons. So how do we detect which ones to install based on your dependencies is one. Do we keep a list of, like, if you're using Rails, install this other gem? Do we allow for a way to configure that in the gem spec so that the gem authors can define which add-on is the one that's supposed to handle the Ruby LSP integration? We don't know exactly what's going to be the best idea, and if you have feedback, we would love to hear that. Or maybe the add-ons should be embedded directly in the gems that they're related to. Maybe there shouldn't be Ruby LSP Rails, it should just be embedded directly in Rails and not be a separate gem. When adding this, we also are going to need to configure the add-ons, because in order to provide richer features, you might need to configure things that are very specific to one add-on and not specific to the LSP. But then we need to do that in an editor agnostic way, because the language server can be used in any editor. So maybe we need to introduce a Ruby LSP configuration file, and maybe you want to have one for your project and one for your user preferences, so we now need a hierarchy of configuration files. So we don't know exactly how we're going to do this, but we can do it with your help, like providing feedback about the current experience, and especially if you hit an issue, reporting that back to us really helps. Many of the issues we find with the Ruby LSP are very specific to your development setup. Like, oh, this only happens if you deny the permission to VS Code at some point, or if you're using this with a dev container. And it's usually very difficult to reproduce. So if you can reproduce, it's extremely helpful to provide that feedback. But I definitely think that we can have a one-click setup experience that will use all of your project's dependencies to give you a very rich experience. Thanks.
Thank you so much, Vinny. Did you want to take a couple of questions? Maybe we'll do like 10 or so.
Sure. Yeah, of course.
And then we can have more mingle time and all that.
Yeah. Go ahead, Steve.
2 questions. One thing we always stuck with extensions is there's quote unquote minimal overhead, just because it's right there in the system and the IDE knows how to take care of itself. What would you say is the difference in overhead support needed to run an LSP versus like a traditional extension? Is there additional hardware requirements? Is it relatively the same? What does that look like?
I think it is a little bit more intense, for sure. because you just end up doing more work than you would if you were embedded directly in the editor.
Got it.
But I don't think it's very significant. It might be a little bit different, but I don't think it's a major source of like slowdown or anything like that.
Cool. It's not like the difference between, say, using RubyMine versus VS Code. It's like not that big of a difference.
No.
Okay. Okay, that's fine. Sweet. The second question, you touched on this a little bit. So around renaming and occurrences, what would happen today if, say, I'm in the middle of refactoring and I decide I don't like the name of my method and I'm going to change that method signature, and now, like any other good editor, it's going to change that reference to that method signature across all occurrences of my code. What would the LSP do in this case? Like how would it handle? It's basically like a bunch of simultaneous file changes at the same time.
Right.
What would happen in the LSP?
You mean how it would be implemented, like the internals?
What would it do? Like, would it actually be able to register all these simultaneous changes at once, or is
Yes.
it? Oh, okay.
Yeah,
Cool.
yeah.
Nice.
The rename request receives basically an array of workspace edits back. So there's a tiny difference between like a regular text edit, which
Yeah.
applies only to the current file,
Yeah.
and a workspace edit, which
Mhm.
applies to anywhere inside your project. So you basically return an array of like, okay, this file needs to have these changes, this file needs to have these changes. It just applies all in one go.
Very cool. Cool. Thank you.
Sure. Yep.
You mentioned that the LSP computes 5 distinct features on each traversal of the AST. Is that a technical limitation? Like, or,
What do you mean?
like, can you do more than 5 in the future?
Right. Yes, but like all of the features that we can execute in the same traversal, they all need to be following the same listener approach. So for example, one thing that we don't compute in the same traversal, but does happen automatically on every key press, is diagnostics for Rubocop. There's no way that we can do it because Rubocop doesn't use our listener approach and doesn't use Prism yet, so it has a different AST representation. So yeah, it is a limitation in certain cases, but for all of the ones that we can, that are implemented in the LSP, all of them we put in the same traversal. Yeah.
I'm thinking that, so in my imaginations that when you type in, you use observer pattern, right? But how about visitors? How did you decide the registers that who are you going to forecast which file? I cannot get the concept about a visitor pattern in this framework, in this gem.
Right.
So what I mean is, what's the object that is going to be notified by visitor pattern?
So the visitor is used to traverse the AST. So we parse the file, you get the AST back with the full structure of the nodes that exist there.
Also, it's full structure of the nodes.
Yeah, and then the visitor, its only responsibility is to move around the AST. So recursively traverse every single node so that we hit every node in the AST. And with the dispatcher approach using the observer thing, in addition to traversing the AST, it also fires events for the listeners that are interested in handling those events. So all of the features are implemented as listeners, and the dispatcher is a generic visitor in a way that will just fire the events for the listeners. So in all of the implementations, there's always the same thing that we do. You instantiate the dispatcher, instantiate all of the listeners that are going to be computed in the same traversal, and then you fire the events. And that will modify the state of the listeners, and then we return the responses.
Oh.
Was that clear?
Yeah. Yeah.
Yeah.
How does it work when like the file you're working on isn't a complete Ruby? Like you delete a bunch of end blocks or something like that. Does it still remember what the file used to have, constants and things like that?
Right. So this used to be a problem until very recently, because the Ruby parser, the original one, was not error tolerant. So basically, if you had a syntax error, the moment the parser reached that error, it would basically say, okay, I can't go on, error, and that's it.
So is this Prism?
Which was, in fact, did make the experience a lot worse in the Ruby LSP. But Prism is an error-tolerant parser. So even if you have a syntax error, Prism always returns a tree, even if it's partial, back to you. So if you have an end missing, we're still going to have the nodes for everything else, and for the place where you would have an end, you'll have like a missing node, signifying that something's missing there. And that's in part also how we're able to display the syntax errors. Because before we couldn't do that. We didn't know where the syntax error was, because the moment it hit a syntax error, it didn't continue processing the file. So you ended up in weird scenarios, like if you had an end missing for closing the class, it would actually associate a previous end with the class and then give you some different errors. So this is all coming from the error tolerance built into Prism.
Sorry, do you talk directly to the file system to look for changes and things, or do you only receive changes over the socket report from the editor? So I'm wondering specifically, like, if I delete files outside of my editor or change files outside of my editor that are not open in the editor, so it doesn't really know about it, does the LSP update?
It does. So the good practice is that you should always trust the editor to send you the text synchronization, and you can register for file watching with the editor, which is what we do. So if you have a file open and you're changing it, it will synchronize the text normally, but we also register for any changes that happen to Ruby files inside your workspace, and then the editor is going to notify the LSP when those change. The only time we read something from the file system is during the initial indexing, because as far as I know, there's no way currently for you to tell the editor, like, hey, give me the contents for every single file in this workspace that I need to index. That you can't do that. So the initial indexing happens from the file system, and then everything else is just from the editor.
So I'm thinking of like cases where I use Vim,
Right.
I might edit a file and then pause my editor, like Control Z, suspend it, and then go into the bundle folder and edit a gem because I'm debugging a gem specific problem. Right?
Right.
The LSP is not going to be aware that I'm like making those modifications to a gem down outside of the project in like another instance of Vim.
You will know if you edit files inside the workspace, but not if you're editing the source files of gems. No. So we don't watch for changes in the source files of gems, because normally those don't change so often. And we have a restart. So if you add a new gem or if you update something and the log file changes, we reboot the LSP. So we don't watch for file changes in gems, but we watch it for your workspace. So even if you had a separate Vim instance and you edit it, as long as it's inside the workspace, it will reflect on the other Vim instance as well.
Okay. Do those Vim instances both share an LSP?
No, each one gets their own.
Okay.
Yeah.
I was wondering if you could speak to the challenges of implementing like a go-to method definition in Ruby LSP, like why that's hard. As someone who knows nothing about building this out.
Yeah, sure. So the first step is you need to index and figure out all of the methods that are available. But there are also other things you need to take account, like the ancestors for a class, for example, because you may be invoking a method that's defined in a parent class. So we also need to index every inclusion for modules, extends, prepends. We need to linearize the ancestors, because you may include a module that includes another module that prepends a module. And so you need the dependencies to be linearized, so that when you're searching for a method declaration, you can basically go the same direction that Ruby is going when it's looking up what to execute. There are also more challenges in terms of figuring out what method a method call refers to. For constants, it's much easier. Like, you have the name of the constant, it's a constant. You can always look it up, and regardless if it's a class or a module, as long as you have the full namespace of that constant, it's always going to be that one. But for methods, if you have, for example, foo.bar, where is bar defined? It depends on what foo returns. If foo may return to different classes, then it may be defined in 2 different places. If you're invoking directly on self, then it might be a little bit easier to determine where the method is declared. You have to account for singleton definitions as well. If you take a singleton definition, you also have the same complexity of ancestors and figuring out receivers and stuff like that. So it's a little bit more complex than constants and modules, classes.
Yeah, that sounds really hard, actually. Yeah. And am I understanding correctly that the Ruby LSP receives like the AST from Prism? Like that's what you're operating on?
Yeah.
And is there like a world where you would just prefer to have the Ruby code so that you could do some sort of like really cheap form of like .source location on the thing I'm hovering my mouse over to do a method lookup? Like that you could use Ruby in the way that it works to do that? You know what I mean?
Yeah, but we don't have access to the runtime though.
Of course, yeah.
So we can't invoke something like a .source location and get the method back. It's all static analysis. So if you didn't have the AST, you would basically need to use a bunch of regexes to try to figure out what exists in the string, or perform some other form of parsing to try to identify what's happening in the code. Which is one thing that actually was raised before, is like someone said, oh, how come IRB can give you the exact completion and the LSP cannot? I was like, well, IRB knows exactly what you have because it's running your code and it has the runtime. So it's just invoking your object.methods, and then you just look at what's available and show those as completion. But figuring out statically, you end up having to, you face these issues of like, okay, what is the type of the receiver of this method? And if you don't know, it's really hard to figure that
Which
out.
seems nearly impossible. And just a really, really fast one, because this is top of mind for me right now. What Ruby version manager should I be using right now?
I don't know.
If you had to pick.
I use CH Ruby with Ruby install, but
Cool.
RBM seems to be the most
Okay.
popular one, is my impression.
Okay, thank you. Yeah.
But then for people who use multiple programming languages, then they usually go for something like ASDF or MIS.
ASDF.
Yeah. Are people using ASDF?
Yeah.
Yeah, and like it? Like, you know, it doesn't give you headaches? Okay. Yeah. Okay. Because RVM is giving me headaches.
You know, or just use a dev container and that's it.
Docker's
Docker.
the best version.
Yeah.
And forget about the Ruby manager.
Yeah, I don't like Docker. Okay, wait.
You know, I was on your boat. I buy the bullet, and yeah, I'm happy. It's good. It's good.
Want to do like 1 or 2 more questions?
Sure. Yeah.
How does the LSP interact with sorbet if you have it in your project? Do you gain any more features or any more knowledge of the code through sorbet typing?
Not yet. We have a little bit of integration. So, for example, because we do use both in our projects, both Sorbet and Ruby LSP side by side. So what we currently do is, if there are features that can be handled by Sorbet, we shut down those features in the LSP. So like completion for constants. You don't need to add a single type signature in using Sorbet to get completion for constants, because Sorbet can figure all of that out without any type annotation. So there's no point in us trying to show completion, because Sorbet is always going to get it right. So we turn it off. Currently, it's mostly based on that, like, is Sorbet present? Is your file typed false? And then we show a little bit more. But what we really want is a future where, like, okay, try to ask Sorbet, did it find the right declaration? And if not, then fall back to simpler behavior on the Ruby LSP. So like, oh, maybe match the method based on the name and the arguments, and just let you pick of the options that are available, which one's the right one. So the full integration is not there yet, but we're working towards that. Okay. Oh,
One more, last one.
Last one.
So, no, I'm just wondering, so I have to have a Ruby running locally, right? I have to have Ruby to run the Ruby LSP.
Yes.
So what if I'm doing Dockerized containerization, editing files that don't actually have a Ruby local, I have a Ruby container running? Like, do I have to run the LSP in Docker in a container? And can it communicate stuff back out to VS Code?
So in VS Code, if you connect there is, and we have instructions for that in the repository, but there is a way to tell VS Code to connect to your Docker container, and then everything works out of the box, because then VS Code will spawn the LSP inside the container. If you use the integrated terminal, it'll be inside the container. So as long as you have that configured, it works. The LSP specification does recommend supporting ports, so if you want to talk to the LSP through a socket, but we don't have support for that yet, unfortunately. And in that case,
I
you
don't
would
do that, to be clear.
Because in that case, he would spawn the LSP in the container and then connect via port and then talk to it remotely. But yeah, we don't have support for that.
Awesome. Well, thank you very much, Vinny, for sharing your knowledge with us. And before we do the remainder of the time, I just wanted to give a shout out to Switch for hosting and sponsoring us tonight with all the food and drinks. So thank you very much. And hopefully we'll see you next time. So again, if you're not signed up to our mailing list, toronto-ruby.com, sign up, and I always email when we've got the next one coming up. So hope to see you guys next time. Thank you.